Hello GTC, welcome. My name is Vasant Mohan, a developer advocate at Mobiledgex on the product management team, and my goal is to make sure that developers have the tools and resources they need to succeed in taking advantage of the unique offering that is telco edge computing. And in the context of GTC, we see so many use cases that involve using a GPU at the edge. And so if you're a developer looking to take advantage of that, you're in the right place. At the same time, if anything I said hasn't made any sense at all up to this point, you're also in the right place, as we'll be explaining all of these concepts in a lot more detail as we go throughout this talk. And to put everything into concrete terms, at the end of the session, we'll walk through a practical demonstration of how you can deploy an Nvidia Metropolis GPU application and get that running on a live instance in Germany on the telco edge. So if you're excited for all of that, let's go ahead and dive right in. To start with, who is Mobiledgex? Mobiledgex is a startup based in San Jose, California, and we were founded back in 2018 by Deutsche Telekom with the expressed goal of becoming a neutral platform that exists between developers and their applications, as well as operators and their compute resources. Now you might ask, what's the advantage of having this unified platform that exists in the middle as a bridge? For developers, it means that they're able to take their applications and workloads, upload that to the Mobiledgex platform, and then deploy that onto operators and guarantee that it works across all these different operators and their edge computing sites. For operators, what it means is that because they don't have compute resources that are located globally around the world, they're able to work together with other operators to provide a cohesive platform to developers for them to deploy their applications. And then that makes it easier for operators to also monetize their compute resources. And that network effect is what we call the telco edge. So hopefully that helps to explain the role of Mobiledgex and what we're looking to build. But I think this also opens up the door to another question, which is, okay, myself as a developer, I have the ability to take my Docker container or my virtual machine, upload that to Mobiledgex, and then Mobiledgex will do the heavy lifting of deploying that container or instance across various different operator sites. And in the context of Mobiledgex, we refer to these as cloudlets. But what's the advantage of deploying on an operator site versus just using regular cloud computing? And there are a couple key advantages that you get by deploying on an operator site. So by deploying on cloudlets, operators will make sure that these compute resources, sometimes these exist, sometimes they build new resources, especially to meet demands of certain applications. But those resources will be typically located very close to cellular towers, and they will be on the same network often. What does that mean? Well, from a practical standpoint, let's take the example of your application backend is deployed on a cloudlet owned by Deutsche Telekom. And let's say I have a mobile device with a Deutsche Telekom SIM card. Now, what happens is that my phone, on my smartphone, I want to connect to that application backend. The data path then becomes your phone makes the connection to the cell tower. The cell tower knows about the cloudlet and knows about the application, so then it sends that network traffic directly to the compute resources that are located close by. And you have this very low latency, low network jitter connection between a device and the application backend. And because this is hosted by an operator, you have all of the advantages of high computation that you would traditionally get with a data center, but from a connection that is happening on a weaker device like a smartphone. And that opens up the door to a wide range of applications because of these two core key advantages, which is lower network latency and lower network jitter. To help you better take advantage of the telco edge, Mobiledgex has a few product offerings. So the first and most obvious is the Mobiledgex Edge Cloud Console. So as the name might suggest, this is your one platform to allow you as a developer to take a Docker image or a virtual machine image, upload that to Mobiledgex, and then once that's there on Mobiledgex, you can define your application needs. For example, what ports you want to have available, have that all consolidated in one form, and then you can use that definition to spin up various instances across various different cloudlets. With that flow kind of established, to better help you manage that application from its life cycle, we offer a wide range of different policies. And these will be auto-scale policies, for example, to help you scale up and scale down based on the traffic demands for your given application, auto-provisioning policies that will allow you to spin up different instances on various different regions and cloudlets, depending on how often those given applications are being utilized. And then finally, also trust policies that better help you manage the network state of your given application. Once you've kind of walked through that management process, we then offer some pretty rich monitoring resources that you can leverage to help you better understand how much compute utilization your given instances are using. Should you consider switching to a higher flavor instance that has more compute power associated with it? And then also, if you integrate our SDKs, we can provide you richer data and insights as to how devices are connecting, where are they connecting from, and that will help you better understand how you can optimize your application to truly take advantage of edge computing. Speaking of the SDKs, our Mobiledgex SDKs are integrated at the device level, and what they allow you to do is find the best edge computing instance for your given device. This really boils down to knowing two pieces of information. So the first is the device's location, which you can get from on a mobile device using your GPS. The second, which is a little more unintuitive, is the ability for you to take the cellular connection and leverage that information to find which cloudlet is being used by a given operator, and that's close by. So for example, let's say we have a device that's located in Germany and there's a Deutsche Telekom cloudlet that's close by, as well as a Telefonica cloudlet that's close by. In our case, to make sure that you have the best edge computing service available, our SDKs will determine what SIM card are you using. Is it Telefonica? Is it Deutsche Telekom? Based on that, then we will search let's say you're using a Telefonica SIM card, we will search the Telefonica network to find the closest cloudlet for you. If the roles are reversed and you're using a Deutsche Telekom network as the end user, we'll then search for the closest cloudlet on Deutsche Telekom. So that is what allows us to guarantee that you have the best edge computing network latency and low network jitter from edge computing through our SDKs. Of course, this does depend on where your application instances are spun up and which cloudlets you already have it deployed onto, but assuming you have it set up correctly and managed properly across a wide range of cloudlets, the SDK will come in to find that best cloudlet for that given end device. As our name might suggest, we work heavily on the mobile spectrum, and so, of course, our SDKs at the device level will support Android and iOS, as well as other frameworks such as Unity, which we are seeing a wide range of gaming use cases come through Unity and then get deployed either to Android or iOS through the Unity framework. And so that's why we specialize also in making sure other frameworks that support mobile devices are supported through our SDKs as well. If we don't have a native SDK, you can always use our REST APIs, which are made available on apis.mobiledgex.net to be able to connect and find that best instance for your given device. And lastly, we offer Mobiledgex Edge services. And this is a pretty recent addition, but we've noticed that sometimes developers will have certain use cases that they just kind of want to have managed for them as part of our own offerings. And so what we've done is we've taken a couple use cases in computer vision and multiplayer gaming and made them available as managed services that you can simply just integrate our SDKs with, and that will automatically find the correct backends for you to leverage. So those are some of our product offerings. And to better put this into context, let's also take a look at a couple case studies of various different developers that are utilizing the edge in unique ways that are very distinct from each other, but all take advantage of the core principles of lower latency and lower network bandwidth. Starting with device synchronization. This is simply the ability to take advantage of the lower latency to send messages to various different devices connected to the edge in a very quick and efficient way. A great use case of this is being built by Forward Games, where they focus heavily on AR multiplayer gaming. And in their case, to ensure that their users have a high quality experience and don't suffer from poor immersion, they want to make sure that the avatars that are aligned to the device are synced and as close as possible one-to-one with what you would expect to see. So for example, let's say you have two players playing their game Score. You want to make sure that the avatars that are associated with the device don't drift off several meters away and create this weird visual jarring scenario where the avatar really doesn't match up to reality. And so by having a lower latency connection, they're able to make sure that their packets are actually being sent across devices and also received in close to real time so that you get that high immersion and high visual fidelity that you would expect from AR gaming. In the context of GPU offloading, which is another big use case that we see, this is the case where you have a smartphone that doesn't have a very powerful compute associated with it, and you want to offload that computation to a higher end device or compute power, which will be hosted at the edge. And the perfect use case for that is remote rendering. This is the ability for a device to just send its input to the edge, and then on the edge to render out your frames, and then send the frames just back to the device. So in the context of AR and VR, what this means is that if I'm moving around with my headset and I want to just send my positional data to the edge, and then the edge will run on a high-end graphics card and compute a very high fidelity visual, which then just gets sent back to the device. And so the device doesn't need to worry about running that heavy computation that requires a heavy GPU. A great use case that's being built out is by our friends over at Hololight, where they are building out remote rendering solutions for enterprise customers so that they have very high fidelity graphics on things that are traditionally require high fidelity graphics like CAD models and enterprise showcases. So it's amazing to see them utilize the edge to really provide a high fidelity graphical experience to their customers. In the case of mobility and location specific data, the edge is very useful because of the fact that you can create so many cloudlets and instances globally across the world in very localized scenarios. As a result, you can take advantage of caching specific data for your application at various different regions and then allow quick access from the device to that specific data. TagSpace is doing an amazing job of this around their location-based events and being able to utilize the fact that they have low latency connections to the edge at specific locations where they can better help their users get the information they need and do that very efficiently. And finally, the last use case is around bandwidth thinning. And we'll be taking a look at that in more detail throughout the rest of the talk. And the demo that we'll actually be doing as part of this talk is deploying the Aicuda Ironyun container from the Nvidia Metropolis program and getting that deployed at the edge. So what is bandwidth thinning? Bandwidth thinning is a use case for the edge where, let's say you have several different IoT devices that are streaming high volumes of data or high bandwidth that needs to get processed somewhere. In this case, we're going to process it at the edge, and then by processing it, we output a small volume of data, which is our metadata or application logic. We can then send that application logic to the cloud or to a device where it can use it in the context of that own application. And this ability to process this data that's coming from high volume and shrinking it down, or thinning it in other words, to a small amount of data is what we call bandwidth thinning. Now you might ask, what does this have to do with the edge? So let's remove the edge from this equation. Let's say instead you have still the same number of devices that are sending their data to, say, the cloud, for example. In this case, you still need to process it, but as a result, you have a large amount of data that has to be sent between the device and the cloud over the internet. And by going over the internet, you expose yourself to having to use an unknown data path that might have several network hops that have to happen between the device and the cloud. If you instead move that logic over to the edge and then have that high bandwidth sent to the edge, as we mentioned before, you know the network path that happens between the device and the edge. And as a result, you have significantly fewer network hops that you need to use. That means you're going to be dropping significantly fewer packets, which means you're going to have a lower network cost that's associated with using the edge. And so by bandwidth thinning that high volume of data, especially when you're looking at scale with hundreds, if not thousands of different IoT devices, those small network packet losses tend to stack up, and that can result in significant costs if you don't use the edge. And one of the most common IoT devices that you'll see out there are video cameras. And that's simply because video cameras can provide you so much rich data to be able to run AI or computer vision workloads on and really get proper real-time analytics. And this broadly falls into the category of IVA, or Intelligent Video Analytics. And this comes in so many form factors with so many different use cases that are out there, from traffic management to factory and warehouse services, to also just transportation controls and operations. And in all of these cases, you have hundreds, if not thousands, of cameras as IoT devices streaming their footage oftentimes up to the cloud. And in many senses, that's really not practical. Up until this point, if network bandwidth was really an issue, you would often have your customers install on-premise edge solutions, where those IoT devices could stream to that on-premise edge and then handle the processing and then send that application data to the cloud. But that does come with the additional cost of having to set up an on-premise edge. By leveraging the telco edge, your customers will no longer actually need to set up that on-premise edge solution and can let that be handled by the telco edge. And exactly as we mentioned earlier, at that point, your IoT devices will stream from the device to the telco edge, be processed oftentimes with an Nvidia GPU to handle that heavy inflow of traffic, and then send that smaller footprint of data off into the cloud to be handled by application logic. And that helps you save both in terms of the physical cost of having to not set up a on-premise edge solution, but also in terms of network bandwidth by leveraging the telco edge as your happy medium to save on that network bandwidth cost. So what's NVIDIA's role in all of this? Well, as I mentioned earlier, GPUs are one of the most efficient ways to process the data streams that are coming from hundreds, if not thousands of IoT devices to the edge, where you will run your AI or computer vision algorithms on them. And then you can take that inference data and pass that off to the cloud so that your application logic can run on that data. GPUs in general are extremely optimized to handle all the mathematical transformations that are needed in order to run your neural network code or any machine learning or computer vision algorithms to efficiently process that data. And to make this process even easier for developers, NVIDIA started the Metropolis program as a means to help out these developers who are building use cases around computer vision, smart cities, and surveillance. And as part of the program, they provide the hardware, the software, the tools, APIs, and resources needed to really make sure that their applications are scalable and can succeed. Additionally, Metropolis provides a validation and certification program where these ISVs can work with NVIDIA to optimize their solutions and then deploy them as part of the NVIDIA NGC catalog. On this catalog, you can see a list of a wide range of containers and Helm charts that can be easily taken and deployed into various different locations, including NVIDIA's Jetsons, as well as the telco edge, which is exactly what we'll be taking a look at as part of our demo. For operators that are looking at the wide range of solutions that exist out there for the telco edge, the NVIDIA Metropolis and the NGC catalog are a great place to look in order to find partners that they can take to build out commercial solutions on operator edges across the world. And here's how that flow would look like. Starting at the right, you'll pick the ISV and their container or Helm chart that you'd like to use that has already been certified by NVIDIA as part of their Metropolis program and available on the NVIDIA NGC. Once you have selected that use case, you can then get that uploaded to Mobiledgex. On Mobiledgex, you'll then have the ability to specify the resources that your application needs and then get that deployed on various operator cloudlets around the world. From there, those applications will then get data streams coming in from IoT devices that are close by and then run on an NVIDIA GPU to process all of that data stream that is coming in. And finally, once that has been processed, you can then send that data off into the cloud for any application logic that you would like to apply onto this processed data stream. And this is not just futuristic and something that is waiting to happen. A lot of this work is already happening today. As I mentioned earlier, Aicuda is one of those use cases that has implemented bandwidth thinning and was able to, as part of NVIDIA Metropolis, deploy their certified container onto Mobiledgex. From Mobiledgex, get that container deployed at a British telecom cloudlet. This was specifically in the context of surveillance for Brexit, and as a result of having their container deployed at the British telecom cloudlet, they were able to take very localized IoT sensors, send that data directly to the edge, and then from the edge, handle that application data to certain devices, which allows them to provide faster and more efficient real-time data analytics and event notifications. But better than me explaining this, why don't we actually go about switching over to a demo and showing how you can do the exact same process of taking the Aicuda container from the NVIDIA Metropolis and NGC, getting that deployed to Mobiledgex, and then getting that on a live working instance available on an existing cloud. Switching over to the demo section of our presentation, we'll be taking a look at how you can get the Aicuda container from Metropolis and from the NVIDIA NGC, download that onto your laptop, and then upload that to Mobiledgex as an image that can be used for the telco edge. If you want to follow along with this, you will need to install Docker and Docker Desktop, which you can get from their website, as we will be using a specific Docker commands here in order to grab the images and move that around. Next, you'll want to create an account with NVIDIA, and you can do so by logging in here at metropolis.nvidia.com, or alternatively, also you can do the same thing over at the NVIDIA NGC catalog. And it'll be the same account for both that you'll be able to use and access these containers. And lastly, you'll want to register for an account at mobiledgex.com, which will allow you to deploy the containers onto the telco edge. So heading back over to Metropolis, here is where you have the list of all of the ISVs that are part of Metropolis and have certified applications that you can deploy. So for example, if you want to say use Deep Vision, you can go to their page and then request access. I've actually gone ahead and done that already with the Aicuda Ironyun application. And so in that case, once you've been approved, you'll see the select this app option. Now, the rest of this page here will go through the deployment process of running a test version on a specific OEM. And you can choose the specific GPU just to kind of get some benchmark testing, which is very, very useful. And I would encourage you to try this out with some of the public examples here, like for example, NVIDIA's DeepStream, which you can just automatically select as an application and try this workflow out. In our case, we'll be specifically looking at a container application, so we don't really need to go through this process. However, if you do want to deploy using Helm, you have this option available to you. So once you've gone ahead and gotten approved by Metropolis, you can then head over to the NVIDIA NGC to get access to the Helm charts and the containers. To get access, you'll want to head over to your profile here and then make sure that you choose the organization that is specific to the container you want to pull. In our case, we have joined the ISV Ironyun organization, and so we want to make sure we select that as opposed to the personal one, and then head over to setup. On the setup page, you'll want to head over to the API keys, and the API key here will be your way of actually getting the container that you want to use. This will allow you to log into the NVCR container repository and then be able to download Aicuda. To get your API key, you'll just want to click on generate here. I've actually gone ahead and done that already, but if you haven't, you'll generate your own key, and then you can follow the commands listed here to pull down that container, which we'll go over in just a second. So now that we know how to get the containers, we need to actually know where this container is stored. So if we switch over to the containers tab here, and then in our case, we're specifically looking for the Ironyun container, so we can search for that. Go ahead and click on this, and this will present you the page for all of the information you need to get started using the Aicuda container. In our case here, right at the top, you'll see the command that we can use to go ahead and pull down the container for Aicuda and Ironyun. And they have several different versions, so if you want to use different versions, you can just simply switch over the version tag and that will work. In our case, actually, we'll be taking a look at pulling down version 4, which was available on the Metropolis page. So with that, we actually have all the information we need to actually get started. So switching over to the terminal here, we'll first want to log in to the NVCR container repository. So in my case, I've already gone ahead and logged in, but otherwise this is where you would put the OAuth token as the username and then the generated API key as your password. Once that's successfully logged in, we'll next want to go ahead and pull the Ironyun container. So you can do that with the pull command with Docker. And again, make sure that you do have Docker Desktop installed, otherwise you won't be able to follow along here. And in our case, we'll be using version 4 as opposed to version 3, which is currently listed on the website. Of course, make sure to pull down the latest version or whatever version you feel comfortable with based on your specific needs. Give that a second to go ahead and pull. In our case, I've actually gone ahead and pulled this already just to save us some time, but this might take a few seconds depending on your connection to pull down the container. With that pulled successfully, we can actually switch gears to using Mobiledgex. First thing you'll want to do is log into the account that you've created earlier, and then you'll be entered into the Mobiledgex main page, which lists all the organizations that you're currently part of. If you've just created a new account, you shouldn't see anything here, but in my case, I have a few organizations that I've already been part of as I've been working here. What you'll want to do is create your own organization. For testing purposes, I've created one for us, but just to quickly walk through the flow, you'll first want to enter an organization name. So for example, in our case, we'll be using Aicuda test. Then you'll enter in your address as well as phone number so that support will be able to provide any assistance for your specific organizational needs. Once you've created that organization, you'll then be prompted to add in your users. In our specific case, your own user will automatically be added to the organization, so you really only need to worry about this if you have other accounts that you want to add here. So feel free to go ahead and skip that step, and then it'll ask you to review your organization. On this page, you'll see 4 different commands here for pushing your container and application to the Mobiledgex repository so that Mobiledgex has access to it and then can use that to create actual instances of these Docker images. Switching back to the terminal here, we can walk through those commands. So the first command will be to log into the Docker repository for Mobiledgex. And then you have to provide your username and password. This will be the same username and password that you use to log into the console. Next, we'll want to go ahead and tag our image to match the specifications needed for Mobiledgex. What tagging is very simply is just a simple rename of a container. So we're going to be renaming the Nvidia container name to match the syntax needed for Mobiledgex. Specifically, the key things that you want to make sure on matching your syntax is that this field here matches the organization name that you just created. So in our case, we'll be using the Aicuda test organization. And then similarly, you'll want to provide an application name and application version. So I'll be calling this one Aicuda test. And in our case, just for consistency's sake, we will be using the same name that we used for Ironyun's version number. This could be completely up to you and be completely different, but just for consistency, I'll be keeping it the same. Go ahead and hit enter here, which will complete the tagging. And finally, what you'll want to do is you'll want to push this newly created image to Mobiledgex. And you can do that simply with a Docker push and specifying the URL that we just renamed this and retagged this to. At this point, go ahead and press enter here. I've actually gone ahead and uploaded a tagged version of this already. So let's now switch gears over to the Mobiledgex console to finish creating our application instance. So as I mentioned before, here's our Aicuda test organization, and make sure the manage button is active. Then we'll want to head over to our apps tab. Our apps tab is what allows us to specify how we want our application to spin up across various different telco edges. So click the plus icon, and then we'll be greeted with a form for how we want to specify our application. In this case, you want to specify the region. So for example, your application could be different across different regions. Next, give it a name. This does not have to match your Docker name, although it is kind of a recommended practice. So I would encourage you to make sure that app name matches. Similarly, with app version, you'll also kind of want to make sure that it matches. This is not a requirement, but I think it's good practice. Then you'll select the deployment type. We have 4 different deployment types that we support on Mobiledgex. There's Docker, Kubernetes, VMs, and Helm. As I mentioned before, if you want to do this process with Helm, you can totally do that as well. But in our case, we'll be doing a Docker and specifically a Docker Compose deployment. For image path, this will be where you would typically, if you just want to do a Docker container deployment, you would specify your image path. In our case, because we want to do a Docker Compose deployment, we'll actually be needing to delete the image path here, but just keep that in mind as that is what you would typically do for a Docker container deployment. You'll next want to select the flavor. So the flavor is how much compute resources you want to provide. In our case, because of Aicuda's need for a GPU, we'll be specifically looking for a GPU flavor, and we can use the Max medium-sized GPU. If you have any questions about specific flavors and kind of the information behind that, you can always check that out over at the Flavors tab within the Mobiledgex console. And finally, we'll want to actually go ahead and specify a Docker deployment manifest. So this is going to be our compose file here that I'm just going to be copying and pasting. So this deployment manifest was graciously provided to us by the Aicuda team. And as you can see here, there's not too much that's going on. It's kind of a very standard Docker Compose file. Some of the key things is making sure that they use a specific version of Docker Compose. And then you'll see here is where our image path has been provided as part of the Compose file, as opposed to above in the Docker image path. And then they set up several volumes that they need for their specific application, and this will always be tailored to your own specific application needs. With that set up, we just need to create 3 ports that we want to make public for our application instance. So port 80, 18, 888. And these are all going to be TCP, and we're done. So let's go ahead and create that application. If you've inputted everything correctly, that should go pretty smoothly. And then we'll want to create our instance. So head over to the Create Instance tab here. A lot of this will already be pre-populated for you based on the application definition. In our case, we now need to select which telco edge we want to provide. We have several different operators that are available. For a specific case, we'll be using TDG. And we'll then need to select a cloudlet, which is just a specific location for our actual deployment. Here, we'll be doing Berlin. You can select multiple instances if you would like, but we'll stick to one for now. That flavor has already been populated for us. And then the next step would be to choose the cluster, which is your specified compute resources that you would like to use. In our case, we didn't specify a cluster earlier, so Mobiledgex provides the auto cluster option. That'll open up a couple options for you to indicate what you want your cluster to do. In our case, we want a dedicated load balancer as part of our cluster, so we want to specify that. If you're doing Kubernetes, you might consider setting up a shared volume. We're not doing that. We also have the option for a bunch of different policies that you can specify, Again, just for simplicity's sake, we won't be diving into too much of that, but we have plenty of documentation on our developer portal, which you can go and take a look at if you want to learn more about our policy offerings. Then you'll go ahead and click Create. That'll start the process of spinning up your application instance, which will take a little while because we need to set up the cluster resources for your application. We'll then need to set up the Docker container on top of that cluster. And so this can take a couple of minutes. So after a few minutes, you should now see all of the statuses in green check marks, which walks you through the process of how the application instance was deployed. Go ahead and cancel out of there and then head over to your App Instances tab. There, you'll now see a map of all the deployed app instances you have created. As you can see, we've created that on the Berlin Cloudlet, and that will be exactly in the location of Berlin. So to actually test this and see that it's working, let's head over to our app instances details, which you can do by clicking on that specific instance, and you'll see a URI field. Go ahead and copy that and then paste that into your browser. And assuming all went well, you should now see the Aicuda login screen. So why don't we give this container a spin? First, gotta go ahead and log in. Once you're logged in, and you can get those credentials by pinging Aicuda, you'll be greeted with the Aicuda interface for Vaidio. And we'll go ahead and close that. On the left here, you'll see the hierarchy, which contains at the top all of the features that are specific to Vaidio that you can leverage as part of the container. And then at the bottom here, you'll see all of the management tools that you can use. In our case, we want to go ahead and set up a video stream. So we can go ahead and do that by heading over to the cameras tab. You'll see here, we don't have any cameras associated with that. And currently we are only using 0 out of 100 utilization. So let's first go ahead and add a camera. In this case, we're going to be adding a camera for people counting. So I'm just going to name the camera people counting. You could name this whatever you like. Next, I'm going to go ahead and set it up for an RTSP stream. And this is just a video stream that's coming in real time. I have one that's already set up here that's actually hosted on my local computer. And this is just some test footage that we can use. With that inputted, I'll go ahead and click Preview, which will then verify and make sure that we're actually getting footage from the RTSP stream, as you can see here in the preview, which is perfect. And once we've verified that, we just need to set up what AI functionality we want to leverage when processing this video stream. In our case, we want to set up people counting. To do that, simply click on the edit function and then drag on an arrow that represents the place in the video stream where the people counting should be activated. And in this case, based on the arrow, you'll see if we have people that are walking in this direction, it'll count that as an inflow of people. And if you have people walking in the other direction, you'll have that as an outflow of people. If you want to reverse this, you can very do so easily by just clicking on the arrow. Once again, we'll just name this people counting and close out of the edit function and click save. This will go ahead, process this, make sure that the video stream and the analytics can be provided. And as you can see in the top right, the analytics resources used have now gone up by 8 points for this specific container. And then to verify that this is working, let's just head over to our people countings tab. And then here, we'll just click on people counting and you can see the stream happening in real time. And we can verify that once these folks walk across the line, that we get a correct inflow that is counted. And if anyone crosses the other way, that we get a decrement. And that again happens all in real time thanks to the Vaidio Aicuda solution. There you go. You see an inflow incremented up and then the outflow from walking the other way is incremented down. So there you have it. There's the Aicuda container working, deployed on Mobiledgex, and this can be set up for a bunch of very different applications, all taking advantage of the telco edge. Great. So where do you go from here? For developers that are here in the audience, what I would encourage you to do is if you have an app that you are interested in deploying on the telco edge, or if you're really just interested in following along step by step with everything that we described in this video, I encourage you to head over to the developer portal for Mobiledgex, get on the getting started page, and then sign up for early access, where you'll have the ability to actually deploy your own containers and solutions onto the telco edge. And if you're not interested in any of those specific applications and you're looking for something that is more kind of ready-made, we've been working with Nvidia to open source a solution as part of their Triton inference server that's also part of Metropolis, and put that together as a demo that you can build off of in order to design a computer vision application that goes and sends images from your phone to the edge to be processed and sends the metadata back to your device. I think that's a really awesome use case, and if you're looking for building on top of that, I encourage you to check that out as well. And if you just have questions or want to say hi and keep in touch, I encourage you to sign up for our developer Discord for edge computing, where you can chat with myself or members of the Mobiledgex team, or just generally edge computing developers that are all building amazing applications. And you can learn about kind of the techniques and the design for building creative applications on the edge. So I'd love to see you there. Thanks so much for watching this session, and I hope you've learned something, and we'll stay in touch. And with all of that said, happy GTC.